Okay, so here you can see that in this case, wha- uh, what are the cutoff values? The cutoff values are f is equal to 8.2 and your cutoff is 3.89 because the alpha you are the alpha that you are getting here, okay, so that is 0.05 you are considering, and the alpha value that you are getting, that is 0.05, and in this case your degrees of freedom are 2 and 12. Okay, so for f distribution comma 2 and 12, the intersection point is 3.89. Okay, so you can understand that your statistic value, it is greater than 3.89. It has come out to be 8.2. So in that case, this case also, you will reject your null hypothesis. That means there is enough evidence that there is enough evidence that age has a significant effect on the student score. Okay, so now the third thing, it is very important, that is the interaction effect. In case of interaction effect, you have calculated the statistic in same way, f is equal to 0.62. Okay, f is equal to 0.62, the same way you have calculated it. Okay, so you can see that this is what is the cutoff value. The cutoff value, if you see that the degrees of freedom here, the 2,12 and the alpha is 0.05 you are using, so your cutoff, you are getting the intersection point 3.89. so this is your cutoff, and you are getting the test statistic value as 0.62. Okay, so you can very easily understand that you cannot you do not reject your null hypothesis. That means gender, and uh, there is not enough evidence that gender and age interaction will have a significant effect on the student score. Okay, so this is your ultimate result. Okay, so here in the first pair you reject null hypothesis. That means there is enough evidence that gender does have a significant effect on student score. In the second pair, you reject null hypothesis. There is enough evidence that age has a significant effect on the student score. And in the third pair, you can see that failed to reject. That means gender and age interaction will have no significant effect on the student score. Okay. So this is the complete procedure of a two-way ANOVA. Okay. So similarly, you can also perform, for example, you can also perform the three-way ANOVA, that you can also perform, and also uh, you can perform four-way ANOVA. Okay, and suppose who are interested to perform, or who want to use a design of experiments method, okay, or DOE, there you will see that usually we are interested to know about the main factor interaction like gender and age. These are termed as main factor interaction, and the two factor interaction, gender and age, these are actually we want to test. But usually the more than two factor interaction we don't want to test. We are only one, we are in majority of the cases we only want to test the main factor effects, main factor interaction effects. That means I mean main factor interaction effects or two factor interaction effects. But usually the higher degrees of interaction effects like three factor interaction effects or four factor interaction effects, these we want to neglect. Okay, because usually it is seen that the higher factor interactions effect interaction has no significant effect on the response variable. Okay, so this is all about that two-way ANOVA. Okay. So now now first I would like to ask you that if you have any query about two-way ANOVA or anything, you can ask me now. Then I will start another thing. Any question, any query? Am I audible? Hello?
Yes, sir.
Okay. I think it is the calculation procedure is little bit cumbersome, but you don't need to do it manually. So don't worry, it will be done by the software. Okay. Uh, as I have said earlier, that I will present one particular case study by means of which you can understand all the tests. When you need to perform which particular test, you will come to know. Okay. But before that, I will discuss that maybe tomorrow or a day after tomorrow. I will discuss all those things. But before that, I would like to tell you one thing. I'm going to stop the recording.